Good evening to all of you. Right, today's lecture is top-down parsing. Right, in top-down parsing, we classified into LR0, right, and LR0 is basically part of the LR parsers, right, and the second one is operator precedence parsing, right. In previous lecture, we already discussed different type of parsing. Now, just for the recap, right? Parser can be classified into two types. First is top-down parser, and second is bottom-up parser. In top-down parser, we classified into two different methodology or two different types. That is called recursive distance parser and LL1 parser, right? In previous lecture, we already discussed what is the type of recursive descent parser and what are the type of LL1 parsers, right? In last lecture, we discussed the bottom-up parsing techniques, right? In bottom-up parsing technique, first we discussed the operator precedence parsing, the only parsing that is deal with the ambiguous grammar. Rest of all the parsing are not deal with the ambiguous grammar, right? Okay. Now, today's topic is LR parser, and LR parser are classified into four types. First is LR0, second is SLR1, third one LALR, and fourth one CLR, right? First two parsing use the canonical sets of LR0, and next two parsings are used for uh, LL1 canonical covers, right? Now, move further some basic concepts regarding the LR0 parsing. If you remember, in LR1 we find out the first and follow. So in this parsing LR0, we construct some different type of functions that is called the goto and closures, right? So move further now. In bottom-up parsing consists of mainly three components. First is sorry input buffer, second is parse stack, third is parse table, right? So we discuss about first one, input buffer. Input buffer means it consists of the input string to be passed and input string end with the dollar. uh, as we know, all the strings are end with the dollar in parsings, right? Parse stacks means the stack consists of a grammar symbol. The grammar symbol are inserted for or remove from the stack using shift and reduce options. What is the shift and reduce? We discuss in next slide, right? And next part is parse table. Parse table is constructed with number of terminals and number of non-terminals and LR items, right? The parse table consists of two parts. First is action and second is goto, right? Action may be called as closer or action and the goto parts, right? So action part consists to shift and reduce option implement for the terminal. If consist of shift operation which are applied on non-terminals, right? Okay, so how to use action and go to, we will discuss in next slides, right? Now, operation on bottom up parsing technique. So as earlier discussion, shift reduce, right? What is the meaning of shift and reduce? So the shift meaning is shift operation can be applied whenever handle does not occur from the top symbol of the stack, and reduce operation can use whenever handle occur from the top symbol of the stack, right? What is the meaning of handles? If we're talking about the production, E tends to SS, right? So when the SS is occur, then we reduce with E, right? Okay. Now, except means the after processing the complete input string of a stack contain only start of the grammar that the input string is accepted, right? And either the processing of the input string if stack does not contain a start symbol of the grammar then input string does not parse and it means parse tree is not constructed, so result says error, right? Is that clear? Now next part, how to construct the LR parsing table, right? So there are three steps. First is obtain the augmented grammar for the given grammar, right? What is the meaning of augmented grammar? In this slide, we discuss what is the meaning of augmented grammar. So augmented grammar means the grammar which is obtained by adding one more production and drives that start symbol of the grammar is called augmented grammar. What is the meaning of this statement? Simple, we can understand with the help of this example. If the given grammar is S tends to AB, A tends to small a, and B tends to small b, right? So in this part, how to augment this thing, right? Then augment grammar is we introduce a one new symbol that is called the S dash. So S dash tends to S, right? And S tends to AB. So what is the meaning of augmented grammar? We introduce a new production, new symbol that is called the S dash, and that is drive this S, right? And the remaining protections are same, right? So this is a part of augmented grammar. Now the next part is create the canonical collection of LR item. What is the meaning of canonical collection? We discuss in next slide, right? On the basis of canonical collection, we prepare the LR parse table, right? So in LR parse table, prepare the table based on LR items, right? So whenever we construct the LR parsing table. So first point is we converted the given grammar into augmented grammar. Then we construct the canonical cover, and on the basis of canonical cover means LR items, we construct the parse table. Now move further and take an example, and we understand what is the basic concept of LR parsing, right? So first point, LR0 items, right? What is the meaning of LR0 item? Right? So a production dot at any point in the right hand side is called the LR0 item. The meaning is clear. What is the meaning of LR0 item? LR0 item means we introduce a dot symbol in right hand side in anywhere, right? So we take an example for this. A tends to ABC, right? This is a production. Okay. Now dot is put in a right hand side in a initial point. So dot ABC is a LR0 item. Now we can place this dot instead of here. We put after A, so A dot BC is another LR0 item. If we put the dot at the end of the all non-terminals or terminals, that is a point. This is a final item. When the final item is occur, it means we can reduce AB with the help of ABC. We reduce ABC with the help of A, right? So I feel the meaning is clear. What is the meaning of LR0 item? Now, canonical collection of LR0 item. How to calculate or how to produce, how to generate the canonical collection of LR0 item. This is an important thing for the LR0 table constructions, right? Now, take us a smallest example so you can easily understand each and everything. Now, S tends to AA and A tends to small a, capital A or B. Now, first we augment this grammar. So what are the rules for augmented of the grammar? We just introduce one new symbol. That symbol name is S dash. So S dash tends to right S. This is a augmented part. Now how to generate the LR0 item? So we produce the dot is in the starting place of right hand side. So dot S, dot AA, dot small a, capital A, and dot B, right? Clear? So I hope so this part is clear. This is an important part, right? How to construct sorry, how to construct the augmented grammar and how to construct the LR0 items. Now, next point. This is an important thing, how to construct the canonical items for LR0. So first we understand what is the meaning of closure and what is the meaning of go to, right? So add argument protection into sorry protection to the I0 state and compute the closure. What is the meaning of closure? We discuss about this thing. Closure means, right, we put the I0 item, forget it for sometimes. We focus on the protection parts, right? These are the protections, right? This is the first part. Okay. Now, how to deal this first part, right? We write it down. Each and every protection is here. This is the first closure, right? This is called the I0 state. Okay. Now, one by one, we shifted this dot to this place to right hand side of the protections, right? And when we achieve the dot at the last part of the protection, that means that is the final state. So we apply this theory one by one and understand what is the meaning of closure and what is the meaning of uh, go to, right? Now, so s dash tends to dot s dash tends to dot a, capital A and capital A, and last protection a tends to dot small a capital A, and the last protection a tends to dot b, right? This is a I0. Okay. Now that is the go-to part. All are our go-to part, right? We expand each and every terminal or non-terminal which is occur in closure, right? Okay. So now for S, right? We expand this part. So go to, this part is go to. Now S dash, we expand the S. So dot is shifted from this place to next place. So the production is S dash tends to S dot. Now, as per earlier discussion, you easily remember this is the final production. Why this is the final production? Dot at the end. So there is no further movement for the dot production. So this is a final part, right? Now, next part for A, right? So for A production, for A go to statement, so we shifted this part S tends to A dot A, right? Okay. Now this is and A dot, right? A, A dot A, right? So again, A production in this closer part. So we again expand this A also. So if we expand this A also, it means this dot is shifted from here, right? So A tends to, right? Sorry, in this part, this is a part of A, right? Okay, so in this part there are the one protection is S tends to A dot A, and the second part is we write the protection of A as it is, right? Dot A, right, slash dot B, right? Now we expand for A. When we expand for A, it means this dot protection is shifted here. So A dash tends to A dot A. And now, okay, A dot, right. Now again, the A is also occur. A is also occur. So we again add these protection is here. So A tends to dot A, small a or capital A, and then A tends to small b, right? I repeated this thing again, right? If there is any confusion, right? When we talking about the go to A means we tackle this part, right? So dot shifted this place to this place, right? So S tends to A dot A. Now after dot, the A is also occur, right? A is non-terminal and the non-terminal protection is available in the closer part. So we, as it is, copy and paste this part is here, right? Clear? Now again we can understand these things here, right? If we take go to A, so it means we shift this dot part to this place to this place. Now, so the protection is A tends to A dot A, right? And again after dot, a non-terminal A is occur. So we add all the protection of A which is occur in closure of S, right, or closure of I0. Clear? Now A tends to dot A or capital A and A tends to dot B. Now next part, when we expand the B means go to B, so A tends to B and this dot symbol is shifted here to here, so A tends to B dot. Again, this is a final production, so we cannot expand further. Now focus on non-expanded part. This is not a sorry, the expanded part. So first this and this, these are non-expanded parts. Now again this dot symbol is occur here, so we can shift it here to here. It means we go to A, right? And when we use go to A, so this is the S tends to A dot. It means this is the final production. Now there is no other possibilities for A. Now again in this part, right, A tends to dot A, right, and capital A slash dot B. So we take care first this part. Now this dot is shifted here, so it means it contain A tends to A dot A, right? And when we talking about dot is here, so already in previous step we discussed this thing. So we introduce all the production of A. So we introduce all the production of A. It means dot A, capital A, or right dot B. So we write it here all the things. So it means when we go to of A, right? So in this part we find the same thing, that is right here. So we directly draw this part to here. When we find out the go to A for this production, so we achieve all these productions. So we directly define an arrow from here to this place, right? This is a part of A. Now again take care for B. Again if we use the B, so B dot is already in your part, right? So again we define this B is here. Now this part is executed. Now take care for this part, right? A tends to A dot A, right? So it means we want to this dot shift this place to this place. So means A, small a, capital A, and dot, right? So this is a production for expansion of A or go to A, right? Now again we take care for this part. So again we find out the same production dot A and dash, right? Clear? So we use the self loop for A, and again same production is find out for B. So we define the arrow symbol from here to here, right? Clear? So this part is okay. Now this part is not further expanded, this part is not further expanded, right? And then we numbering, right, is of the state. This is I0, this is I1, this is I2, I3, I4, I5, I6. One thing is, remember, it is not compulsory. You can write the state I0, I1, I2, I3, I4, I5, I6, right? But in a systematic manner, right, in each and every labels, right, we define a state. So this is the first label, so I0, this is the second label. So in this label, all the production are number according to that, I1, I2, I3, I4, and this is the next label, so I5 and I6. It be further move further, then I7 and then I8, right? Okay. Each and every part I write it down in a next slide. If you have any problem, you just go through the statements, so you can easily understand each and everything, right? Here we write down each and everything, how to calculate the closure and how to calculate the go to part from one state to another state, right? Now next part is how to construct the LR0 table, right? So if the state is going to some other state on terminal, then it corresponding to the shift move. What is the shift move? In previous slide we already discussed what is the shift move, right? So you can easily understand the meaning of shift move. Now if a state is going to some other state on a variable, then it corresponding to go to the move state, right? If a state contain a final item in a particular row, then write the reduce node, right, completely. What are the meaning of these statements, right? We clear one by one. how to fill this table, that is the most important issue, right? So take care for this part, right? Okay, so each and every state is write it down here. So total state is I0 to I6. It means 7 state. And what are the terminal and non-terminal? So check it this grammar, right? Terminal symbol is A and B and dollar, and non-terminal is S and A, right? We don't consider this grammar. We consider this grammar only, right? Okay, not on augmented grammar. Okay, so AB dollar and A and S. In variable part, in terminal part, right, we use the keyword action, and in non-terminal part we use the keyword go to, right? Now the next step for I0 state, here how to fill these things. Okay, so check this. For I0, right, the small a, first we focus on the terminal parts, right? So small a, we achieve the state I3, right? So when the terminal is occur, right, we write it down the state with the help of symbol S, state, right? S3, shift 3, right? It is the meaning of shift 3, right? So when the I0 state A is occur, we shift it for the next state, right? That is called the S3, shift for third state, right? It is the meaning is clear. Now for B, we check. Now for B, if we talking about the B, so we achieve the state I4, so write it down S4, right? Clear? For I2, again for A and B state, for I2, for A and B, for A and B, again I3 and I4, it means S3 and S4, so S3 and 4, right? And same as for I3, I3 for A and B, that is I3 and I4, so again we write it down S3 and S4. So variable part, sorry, terminal parts is clear, right? Now non-terminal parts, how to tackle the non-terminal parts, right? The terminologies are different. Here we write it down the symbol S3, S4, right? Now in this part we write it down only the numbers, right? So please check this thing. These are the final productions: I1, I4, I5 and I6, right? I1, I4, I5 and I6. These are the final productions. Clear? So when I0, right, for capital A, I0 for capital A, right? In I0 capital A, according to this, we achieve the state I2, right? So we write it down is here 2, right? Clear? For B, for, okay, sorry. Uh, for these things, uh, just a minute. Okay, so for the non-terminal, right? If we take care for I0 for A, check here I0 for A we achieve 2, I2, right? And I0 for S we achieve 1, right? Clear? And in I2, if we put A, so we achieve the state I5, right? And in I3, if we put non-terminal symbol A, then we achieve I6. There is no another non-terminal symbol. So S, A. So we take care A, 1, 2, 3, and 4. 4 entries, right? So for I0, for S, 1, right? For I0, for A, 2, right? For I2A is 5, and for I3A is 6. So you check it here, right? 2, 1, 5, 6, right? I write it down. Each and everything is here, right? So I feel there is no problem to understand, right? Now move on the next part. Remaining entries. These are the remaining entries. What about the I4, I5, and I6, right? So according to this diagram, I4, I5, I4, I5, I6, right? These are the final state, and I1 is also final state. Where the augmented grammar, where we use the augmented grammar production, we always use the accepted state that conditions, right? So dollar, it means the last in input string, always the last symbol is dollar, so that is the acceptable state. So in this point we always write it down the accepted state, right? So I1 इन I1 हमें क्या मिल रहा है आपके पास में, this state is achieved, right, as there's two s dot. It means we, if the dot is occur in a last part, so we go through all the productions. So this is the acceptable states, right? So we write it down here, accepted state. And what are the remaining parts? So we'll discuss what are the remaining parts, right? So in this part, right, we write down the accepted state. Now for I4, I5, I6. So move one step further, right? We numbering of the productions, right? These are the productions. So this is the first number production, this is the second number production, this is the third number production, right? In this example, this is a 1, this is a 2, this is a 3, right? On the basis of this production number, we fill it this entries, right? So I4, right? You check it here, right? Clear? So I4 contain the A tends to B. So see it here, I4 contain, right? In I4 contain A tends to B dot, right? So A tends to B dot, what is the production number of A tends to B is 3, right? I4. So in I4 we write it down, each and everywhere is R3 in action part only. Same as in I5, check here, I5 production, I5 is S tends to AA dot. AA dot means this is the first production, so we write it here R11, right? And the next part is R6, right? Sorry, I6. I6 is contain A, small a, capital A dot, right? This is the production number 2, so we will fill it here R2, right? So this is a part of the parsing table, LR0 parsing table, right? And same as if you want to satisfy any string, right? You take care one string, and the same method we'll discuss in L1 parsing techniques using the stack method, right? You can easily satisfy the string with the help of these parsing table, right? This is a parsing table. So in next lecture, we take a one example and discuss how to use this parsing table for a given grammar and the input string. Thank you so much. And we meet tomorrow. If you have any doubt, you can contact me on my number, right, or my email ID, or you can call me. Thank you so much.